Sierpinski problem, and it's kind of a problem where we all wonder about and notice it, but we never formalize it, I think. But we want to make sure that each of the integers in the sum is greater than 1. And let me just write this. You probably already see, but notice that n is equal to certainly n minus 1 plus 1, right? Right. And so certainly n minus 1 and 1 are relatively prime. So that's not interesting, and it's not even worth mentioning, really, right? But that's why you have the greater than 1 right here. So n minus 1 and 1 would do the trick if you allowed 1 in your representation. Okay. Now I'm going to break this into even and odd. Odd's fairly easy. If you take a look at a prototypical odd number, let's call it the usual 2k plus 1. That's an odd number. But notice that we can write this as 2 times k minus 1. And this you can figure this out just with a little bit of discovery. I'm just writing down. I'm not going to go through the discovery with you. Plus 1, right? Okay, but then plus 2 right here. All right, folks, does that all add up? Yeah, the minus 2 right here cancels with this 2, right? And so that means that 2k plus 1 can also always be written like this. Okay, it can be written like this, and these are relatively prime because this is odd and this is even, right? This is an odd number and this is an even number, right? And so you can't have these two numbers would be relatively prime, right? Okay, I won't write that down, but these two numbers, this number right here that I'm underlining, this number right here are relatively prime. Okay, so the odd case is fairly easy. Now the even case requires a little more care. Any even number is either in the form 4k or 4k plus 2. Why? Because the only other possibilities would be 4k plus 1, but that would make it an odd number, or 4k plus 3 would make it an odd number, right? So every even number greater than 6 has this form. Now, let's take a look at the 4k case. It's very easy, right? These two numbers are definitely relatively prime, right? Consecutive odd numbers share no common factors. They're relatively prime, right? So that's trivial. Now, the 4k plus 2 case was slightly more involved. You can write this as 4k plus 2 equals to 4k plus 3. So this would be odd numbers separated by 4, consecutive odd numbers, if you will, separated by 4. Now, so we assume that if this is equal to d and it's greater than 1, okay, some d greater than 1, meaning we assume that it's not relatively prime. Now, notice that if we have the simple, if 5 divides 25, right? But 5 certainly also divides negative 25. And that's the only truth we're using right here. This is just a special case of what I'm trying to illustrate. See how I switch these around? Okay, d must divide, if d divides 4k minus 1, it also divides the additive inverse of 4k minus 1, which is minus 4k plus 1. Okay, so that implies d divides 4, but we know that d is odd, right? We know that d is definitely odd based on the way we've defined it right here, right? Okay, because it's the greatest common divisor of two odd numbers, right? So d is odd. So the only odd number that could divide 4 would be 1, right? Okay, so you see we get a contradiction here. D does have to be equal to 1. Now this is just probably something I could have just proved, for odd consecutive odds that are separated by 4. That you could make that a limb if you wanted, and we actually just did a mini proof. Well, a comprehensive proof, I would say. Okay, so we're done because in the 4k case we got consecutive odd integers which are relatively prime. Okay, in other words, I'll write this in 2k minus 1, 2k plus 1 are definitely relatively prime. I'm not going to try to prove that. And in a similar fashion, we've just shown these two numbers right here, 4k plus 3, (4k minus 1) is relatively prime. So that takes care of business. Any number satisfies this, and if you play around with numbers, you'll notice this is true. But I think breaking it down into even and odd, parity sort of proof is the way to go here. So that does it, folks. The proof is complete. So thanks for viewing.